Alright, here I've got a typical problem in physics in forces. We've got the sled problem. Let's call this sled number 1. We'll call this one number 2, and we'll call this one number 3. They're attached by ropes. This rope is a force of 200 newtons on it. This one is has a force T2, tension in this rope and tension in this rope, and the question is what are the values of T2 and T3? I know the mass of each sled is 50, 50, 50 kilograms, and the friction, I'm not giving you a mu here, I'm going to make it slightly easier. I'm just going to tell you what the force of friction is total on each one. So in the last video on pulleys, I said step 1 we drew a system diagram here. Step 2 is we draw a free body diagram for each one. So I've got, this is sled number 3, I've got T3 pulls it this way, friction pulls it that way, I've got FG, I've got FN, here's number 2, T2 is this way, FG, FN, and T3 is slowing this down, and friction is slowing this down. And then the last one, I've got this force of 200 newtons, I've got FG, I've got FN, I've got T2, and I also have a force of friction. So here's my free body diagrams. The next step is to say that, to write an equation for net force for each one. So here F net is equal to T3 minus force of friction. Here F net is going to be equal to T2 minus T3 minus force of friction. And remember, we're moving this way, that's why I chose this first. It's going to be this minus those, because we're moving this way. And here I get F net is equal to 200 minus T2 minus the force of friction. The next step is I put in A here, so it's MA equals T3 minus force of friction. MA equals T2 minus T3 minus the force of friction. And here I get MA equals 200 minus T2 minus the force of friction. Now I need to solve these things simultaneously. The A's, I've got A's, I've got T2s and T3s. I think what I'm going to do here, I'm going to use substitution. I see here, if I rearrange this guy, I get T3 is equal to MA plus force of friction. And over here, if I do the same thing, I would get T2 equals 200 minus the force of friction minus MA. Yeah. Bring this guy over, that guy over, yeah. And I'm going to take both of them and I'm going to put them up into that guy. So I have MA, that's good, equals T2. Now instead of writing T2, I'm going to write all this. 200 minus the force of friction minus MA. Now minus, just write all that, minus T3. So it means minus MA minus the force of friction. And then minus the force of friction. So once again, I've got MA equals T2. I wrote all of this, 3 terms, bang, bang, bang. Then I'm going to take away T3, means I'm going to take away this and take away that, and there are those terms right there, and then I still have this last force of friction. Do that. When I bring the MAs to the other side, I'm going to have 3 MAs. When they come over, they'll be plus, equals 200. Force of friction is 15, and I've got 3 forces of friction. Take away 1, take away 2, take away 3. Yes. I get 3 A is going to be equal to 200 minus 3, I think I said 15, all divided by 3, and I think I said 50. Let's just go back up and check that, shall we? Each one's 50, force of friction is 50. So I'm going to get 200 take away 45 all over 150. And that's almost equal to 1. Yes. Now I have A. I can go back up here and solve for T2. So therefore T2 is going to be 200 minus 15. I'm just using this formula right here. Minus 50 times 1, which is what, 130 or 135? Yes. And then I can also do the same to find T3. I'll just use it right there. It's going to be 50 times 1 plus 15. And so that's 65 newtons. So, and I'm happy about these answers. Why? T2 is much bigger than T3. And that makes me happy, because when I look at this, shouldn't this be bigger than that? Because isn't this pulling this sled and this sled? If I had gotten them opposite way around, I would have questioned it, but I'm happy that T2 came out much bigger than T3, because T2 is carrying this sled too. T3 is really only pulling on the third sled. So this is a really classic question in physics, sled questions, but they're all very similar. We draw a system diagram, we draw free body diagrams, we write equations for net force, we put in MA for Fnet, and then we solve simultaneously. In this case, math was a bit more difficult, but still doable.